That'll probably answer your question quite well right off the bat. So the next part is the follow me controller, which is on here. And for this, we actually need less parts than the other two things. Well, you can, if you use a screen, you'll need about the same number of parts as the checker, but the minimum necessary parts to use this is just an Arduino and an RF module. So, bring this down a little bit more. So this little piece of plywood is actually, I took this out of the YMFT flight controller that I had for one of my wooden quadcopters at the beginning of this year. So it has an Arduino Pro Mini 5V. This one really has to be a 5V one. I originally started using this with a 3V one with a level shifter to talk to the clean flight, and it just, I couldn't get it working at all. And everything came right as soon as I started using the 5V Arduino, so that it's sort of at the same logic level as the flight controller. Flight controller is over there, that is a Flip 32. And of course, it goes without saying, I think that maybe I should have mentioned at the beginning, but to do this you're going to need a quadcopter that's set up and using CleanFlight iNav specifically. I don't know how many of the CleanFlight iNav changes have made it into the regular CleanFlight yet, but I know that this will work with the iNav branch of CleanFlight, probably not with the regular CleanFlight, definitely not with Betaflight or anything like that. But anyway, you'll need to have a quadcopter that's set up to do autonomous stuff like return to home and position hold and things like that. Anyway, so back to the controller. So being a 5V one here, I have had to use a little voltage step down regulator to power the radio module. So this is again at 3V. And I think I did actually set this one to 3V, not 3.3, because if you're using 5V signals, according to the datasheet game, you should be powering it with 3V instead of 3.3. Anyway, so that's the antenna there, just goes down there. Again, a couple of little capacitors on there seem to work quite well. Over here in the top corner I have an accelerometer, but that's only on there because, like I say, I took this out of the quadcopter that I was using at the beginning of the year, so that's not really necessary. I just have it disconnected there. Right, and we have some wires coming up here. Let's look at these two wires here. So black and white are ground and VCC, and then there's a couple of wires there which are a little bit hard to get at, but they are, these ones there, blue and the green one, and they are making their way up to here at the top. So at the top I have another one of these OLED screens, and this is the piece I was saying is optional, but again, if you don't have this, you're going to be pretty clueless as to what's going wrong if you have problems, and I'm probably not going to help you much if you don't have this on there to at least get some feedback about what's going on. So that's that one, and then there are three other wires here, and this one's coming from ground, and these two are coming from, in my case, pins 5 and 6. I prefer to have them 3 and 5 because these are the faster PWM outputs 3 and 5, but this pin here, my pin 3 is going a bit strange. I can't solder onto it properly. It seems to be, I don't know, it just doesn't take solder, so I'm using pins 5 and 6, but I've made the sketch to use 3 and 5. And if we follow those over, the blue and the purple one go all the way around here. And it was a bit awkward to try and show you, but if I turn this carefully, we'll see that those are going into the gimbal control board at the top of the gimbal. And those are used to direct the gimbal pitch and yaw so that the camera points at the tag while the quad is flying. Of course, you don't need to have a camera gimbal to do any of this. It's just it gives you a nicer result if you do. Right, so let's power this up and see what we can see. Oh, another thing I didn't mention is that there's a little LED on pin 2. So this is just ground and pin 2, and then there's a small resistor between them, so that it's not just, too much current going through there. Just a current limiting resistor, that's what it is. All right, so if I power this up, and I've left the follow me tag outside on the veranda. It's still running, still broadcasting. So first thing we notice is that the LED is blinking off and on, and it turns off or on, it toggles every time it receives 5 packets from the tag. So this lets you see, it's kind of like a heartbeat, to see that there is radio packets being successfully received from the tag. Oh, okay. And you can also see roughly how many, or how fast they're coming in by the speed that this changes at. So it's probably about, what was it, like 10 packets per second or something before? It'll probably something like that at the moment. Okay, probably more interesting though is the screen. Let me just get this in view. It's a little bit awkward to see with the sellotape on there. Alright, so here we have, again, packets per second is around 50. Oh, that's good, isn't it? And then the RC is the current value of the roll stick of your transmitter. So some of this information is coming from the radio out on the veranda. Some of it is coming from CleanFlight itself. So let me just I can keep this all in view. I don't think I can. Oh. So I'll just turn my radio on and just put this here. No, this is awkward. Okay. Yeah, let's focus that way. Alright. So you see the number RC5 in the top right. This lets you check. If I move my roll step to the right, it should go to 10. It's a little bit slow to react. But when it's in the middle, it should be 5. And if I take it all the way to the left, it should be 0. So this is, just to let you see that information is being pulled from the clean flight controller successfully. That's only one piece of information. We can see also their altitude. Just turn that off. There's two numbers for altitude. One is the altitude of the quadcopter, that's the one on the left. And then the one on the right is the altitude of the follow me tag outside. So I guess the veranda is a little bit lower than when we have the desk. And the important point to note here is that when you turn each of these on, they should be at the same altitude, so that they both record the same altitude as 0. Because some of the flight modes, the quadcopter will try and put itself at a certain altitude above the tag. So if they're not both started at the same altitude to record 0 the same, it might not work out too well. After that we have yaw, and again there's two values. So yaw, the left one is the yaw of the quadcopter, well it's actually heading, but heading's a bit wrong, so I just called it yaw, just to save space. So that means it's heading 21 degrees. So if I turn it a little bit to this way, I should be able to get it to face due north. I lose focus. Alright, so around about there. So now the quadcopter is pointing due north. So that is north. The second number, in this case minus 69 at the moment, is the angle that the camera gimbal needs to be turned to point towards the follow me tag. So these numbers sort of work together. So you can see if I put it to, now they're 1 and minus 69, if I move it to here, then now it's 0 and minus 68. So they're always going to be 68 apart for the current position of the quad and the follow me tag. So if I go around here, if we get it to 10, now it'll be 10 and 78. Or minus 78 that is. So what that's doing, that minus 78 degrees, is telling us, see the camera gimbal move? This is another way that you'll be able to tell whether everything's working okay, is that you should see this pointing towards the follow me tag. It's not going to work very well at the moment because the quad is indoors, and like I say, this GPS module being an M8N, it's quite a good one, so it does actually pick up a decent GPS signal even inside, but it's not going to be very accurate. So at the moment, the follow me tag is more like about over this direction, not that direction. But the point is that as you move the quadcopter around, the camera should maintain the same direction. So it's pointing pretty much directly towards me at the moment. Well, not quite, but it's so the camera is pointing in this direction along this line, and if I turn it around, it should go back to that position each time, like that. And it's a bit slow, you'll notice, because it has to react to how the quad's moving and doesn't know where to go until the quad moves somewhere. So it can only follow after what the quad does. Which is a bit unfortunate because sometimes the quad turns quite quickly and the camera lags behind a lot like that. And you'll see this in the video that I'll show you in a bit. But it's not very pleasant to watch. But the reason that it happens is because the gimbal is kind of made to smooth out these movements, and it's set to pan mode for yaw at the moment. Anyway, so it's probably enough about that. We'll notice one thing down here that we'll see in the video as well. I had a problem with this gimbal in that all of a sudden it was working fine. I used it for about 2 or 3 hours, well not that long, a few flights, and then all of a sudden I found that when it got to 45 degrees or so over in this direction, so when it turned itself to about there, it would just lock itself rigid and stop working. And it turned out to be I2C errors. And with a bit of investigation I found that it was to do with this wire going through the yaw motor. It was having trouble, the signal just wasn't clean enough to read properly. So what I've done here is I took one of these same kind of wires off one of the other gimbals that I had that got a bit broken, and I connected this wire up directly from the gimbal controller board to the IMU on the bottom of the gimbal plate that's right underneath the camera. And it's not going through any of the motors at all. It's completely free and outside of all of the structure of the gimbal. And that works fine. So it's a bit of a nuisance though, because what it means is that I haven't really stuck it down anywhere, I probably could. But we're going to see this wire occasionally coming into view of the camera like this, depending on which way the camera's facing. So that's a bit of a nuisance. So it's totally unrelated to this project though. Just thought I'd mention it in case you're wondering why there's this wire poking up in the camera view sometimes. Alright, so what else is there to check? Let's go back to the screen again. We have... Okay, so that's your. Left one is the current heading of the quadcopter. The right number is the bearing relative to the quadcopter that the camera should be angled to. So when this second yaw number is 0, that means that the camera will be facing straight forward relative to the quadcopter. Negative number will be facing to the left, positive number will be facing to the right. I'm not sure if we can see it there at the moment, but... Alright, so this is facing almost 90 degrees towards the left of the quadcopter, and I can see right now it says minus 93. I'll see if I can bring it back over here without it changing. Okay, oh, minus 93, good. So that's what that means. So minus 90 degrees means 90 degrees to the left. Right, the mode. The next one is mode, and I had planned for this to be showing one of the modes that it's in, so it's like fixed radius or fixed offset or overhead, or there's a couple other modes that I made. But for the time being, all it does is change between 0 and 1 when the follow me mode is engaged. So to do that again, turn my radio on, and you can see the number 5 changing to 10 at the top, so I'm controlling the roll stick on my transmitter again. And if I turn my switches to the position where this follow me mode should be engaged, we'll see that mode number change to 1. So that is 1, obviously. So that's just telling us that it thinks that it's doing follow me right now. Of course, it's not going to get up and fly because it's not armed and it's not, the flight controller is not in the right mode or anything like that. And finally, the last line on the screen shows the, it kind of depends a little bit on what each of these numbers means depending on which mode that you're using, whether you're using fixed offset or circle or fixed radius or whatever. But they are the offset of, I think it's the, let me get this right, it's the target offset from the follow me tag that the quad should position itself at. So in this case, it's 0, 0, 500, meaning that it should position itself at the exact same lat and long, so the number is a lat long altitude. So 0 and 0 means it should position itself at the exact same latitude and longitude as the follow me tag, and the altitude should be 5 meters, so this is 500 centimeters above the follow me tag. And the reason that we ended up with this is because in the mode that it's set to use at the moment is overhead, which means that it's going to position itself horizontally at the same place as the follow me tag, but above it. And this 5 meters is just a safety value because since the quad and the tag are going to be in the same place horizontally, they can't also be in the same place vertically, otherwise, you know, it might be a bit painful. So that's why it's 500 in this case. But these numbers will change a little bit depending on what kind of mode you are